Here we are going to solve a system of linear equations using Cramer's method. So consider a general system of linear equations consisting of three equations. So the AIs, the BIs, and the CIs and the DIs are the constants. So these are all constant terms, these are numbers, whereas x, y, and z are the variables for which we need to find the solution. When we use Cramer's method, we need to find four different determinants. Let's call them d, dx, dy, and dz. For d, we copy the coefficients of x, y, and z, which are on the left-hand side of the equation. For the x, the first step is to copy the same coefficients first. Now, since the x is related to the variable x, we are going to delete the coefficients a1, a2, and a3, which are the coefficients of x. And we replace them by the coefficients, the constants of the right-hand side, d1, d2, and d3. We do the same thing for dy. So now we remove the coefficients of the variable y, which are b1, b2, and b3, and replace them with d1, d2, and d3. We do the same for dz. We remove c1, c2, c3, and replace them by d1, d2, d3. Then you need to compute these four different determinants. Finally, you take those results, and x, the variable x, would be dx over d. Y would be equal to the value of the determinant dy over d, and z is equal to dz over d. So that would be your solution. So next we consider a particular example. Let's start with the determinant d. We copy the matrix of coefficients. We copy the same matrix of coefficients, and for dx you replace 4, minus 2 and 3 with the constants of the right hand side, 8, 12 and 5. The same thing is done for the y and the z. So for the y we replace the second column. For the z we replace the third column with 8, 12 and 5. Now you compute the determinant of these 3 by 3 matrices. The results would be 98, 196, 490 and 98. So finally x, the value of x is dx over d, which is equal to 196 over 98, which is equal to 2. Y is equal to dy over d, which is equal to 490 over 98, which is 5. Z is equal to dz over d, which is 98 over 98, which is equal to 1. So the unique solution is x is 2, y is 5, and z is 1.